Most of people really missed what can you do with 100% guaranteed structured output from OpenAI. So OpenAI released this new feature a few weeks ago where they promised 100% guaranteed performance for structured output. And this just totally changed how I develop AI application. For example, if you're building AI agents, as the agentic system became more and more complex, it is really challenging and painful to get agent perform consistently. So 1 out of 100 times, agent might behave totally different. And this structured output feature is going to really help and change that. It is basically a feature that's going to guardrail and force large language model to output the result in specific data structure, which kind of promised a lot of interesting use case, like enhance the reasoning ability by forcing it to think step by step, extract data from unstructured information, or even dynamically generate UI based on the user intent. But getting large language model generating specific JSON output is not really any new concept. What's really mind-blowing was OpenAI promised 100% guarantee for the output structure score with the latest GPT-4o model. But is this actually that good? And when should you care to use it at all? So for the past few days, I've tried to experiment with different ways I can use this structured output feature and explore different use cases, including web scraping for very complex data structure, building generative UI application, as well as agentic application that can automatically finding the highlights of video and extract short clip. So I'm going to show you with my learnings what worked, what didn't work, and when should you leverage the structured output feature. But before I dive into this, I know many of you are building voice-related language model application. And one challenge you might find is getting extremely accurate audio transcription in multiple different languages. That's why I want to introduce you to Assembly AI. They are a leading speech-to-text model provider. They can provide extremely accurate transcription for both audio and video, whether you are dealing with English, Chinese, French, or even Spanish. And it does more than just transcription, but also out-of-box audio intelligence, like automated topic detection, summarize the content, as well as speech recognition. And it's extremely easy to getting started. They provide SDK that you can use right away. And my personal favorite is that they allow you to define custom spelling for domain-specific words that is not that well known. Like I can define special words like land graph and land chain, and then the transcription will be able to identify those words accurately. And if you're building real-time AI system, Assembly AI offers low latency real-time streaming. It is extremely fast, and you can get things transcribed as they happen. I have put a link in the description below where you can click to get $50 worth of credits for free. And I also utilize Assembly AI's accurate transcription ability to build an AI video editor that can turn any long YouTube video into small shorts. You can jump to that to get example of how can you set up Assembly AI. And now let's get back to OpenAI structured output. Firstly, let's quickly talk about how does it actually work and why this is such a big deal. As I mentioned before, getting large language model to generate structured output is not a new concept, because the real-world scenario is full of structured data. If you are building a large language model application to automate data entry and data extraction work, it has to follow specific JSON schema so that you can put them into a CSV or database. On the other hand, if we are building agentic software where it needs to interact with different systems, to call those APIs, we also need to making sure the answer follows specific API schema. And people also found structured output means structured reasoning. So you can not only get the large language model to think step by step, you can even teach it to think in specific ways and process by defining the specific key in the output structure. And previously, we kind of hack our way through by adding specific prompt about the data structure that we want in the JSON mode. And there are also open source library like Instructor to enable large language model output the structured data more reliably with mechanism like retry if it didn't generate intended result at the first attempt. But the problem of this existing approach is often that it is not 100% reliable. There will be 1 out of 100 times it will output something not following the specific structure I defined, especially when the data structure becomes more and more complex. And this is why this 100% guaranteed output score is such a big deal. And to achieve that, it was not just based on model. They mentioned no matter how much they try, the GPT-4o model itself can only achieve 93% in their benchmark. And to get 100% guaranteed performance, they took a deterministic, engineering-based approach to constrain the model's outputs. If certain symbol like curly bracket has already been used, then the curly bracket is no longer a valid token to be used. And this is exactly the constraint that they add to the model. So they turn every JSON schema into a specific grammar the large language model has to follow, and their inference engine will determine which token are valid to produce next based on the previously generated token. So it is really interesting approach they're taking. So how exactly can you use it? Basically, there will be a field called response format, where previously you can only pass on JSON object type, but now this response format can take in specific JSON schema. And inside JSON schema, you can define very specific data structure. Like in this case, you want to extract person, where each person will have a name, email, and account ID. And there are two ways you can define the structure. You can either write in the whole JSON schema, like what you just saw earlier, but you can also use a library called Pydantic. And Pydantic is one of the most popular open source data validation package on Python. Pydantic library is initially used to solve the problem where in Python, there's no concept of static type, which means each variable can be any type of type like string or integer at any given time. And this nature of lack of type is good in a way that it makes it really easy to getting started, but also causing a lot of problems later on. Like you might pass on a variable's value to be string while the expected value is integer. But with Pydantic, you can create a specific data structure. And for each field, you can define the data type and even add description so that you can add more rules and requirements about how you want this data to be added. It's very extendable to create more and more complex data structure by wrapping different Pydantic model together. And it can also limit specific options certain key can have. And Pydantic model will automatically validate if all the value has been generated in the required format. And there are also advanced usage where you can build custom validator if certain field not only follow certain types, but also custom rules that you can program to get more deterministic behavior, like making sure the account ID or the price tag generated is within certain range. So as a quick example, I can create a Pydantic model called person with name, email, and account ID. And for each field, I can define the type, as well as adding a description to further prompt the large language model about how this data should be generated. And you can also put a custom validator here to check if the length of this account ID is not 4 digits, then error out. And then all you need to do is just set up a response format to be this Pydantic class that you define and run it. So if I run it here, you can see it return me the format in exact way that I want it. And as a contrast, you can remove this description and generate again. And this time it will error out, says the account ID must be 4 digits. So this is how the OpenAI structured output works. And next, we're going to dive into when should you leverage this structured output feature to build a much more reliable and powerful large language model application. I'm going to break down into 3 different categories: complex data extractions and boosted reasoning ability, as well as building more reliable agentic workflow. So firstly, complex data extraction and web scraping. One of the most wonderful ability large language model provide is that ability to extract structured insights out of unstructured data, like website content, PDF file, or even books. And people can already use large language model, even JSON mode, to do simple data extractions, like looking at a website and getting the company name, address, city, phone number, pricing. And this structured output function obviously going to make this simple use case more reliable. But where it really shines is those complex data structure. Like if you want to scrape a e-commerce website, where it can be hundreds of different products, and each product can have information like product name, rating, pricing, material, and sizes. Or you are scraping a restaurant website where you want to extract the menu item, and for each item you want to get the name, ingredients, and price. So for this type of complex data structure with huge volume, it is typically quite a challenging task for large language model to deliver reliably and consistently. And this is the first thing I want to test out to see if it delivers the result promised. So I quickly set up a Streamlit web app where it can take any web URL and extract data in any specific type of format that you can define above. I'll showcase full code of how you can set up this whole app in the end of the video, so you can jump to that if you want. But as a quick example, I want to scrape some restaurant menu data. So I'm passing on a small restaurant's website. It can have loads of different items for food, wine, and drinks. You can see here, there's probably around 50 to 100 items. So it will be pretty challenging for the normal large language model. I would define data model where it has menu. For each menu item, it will have the name of this item, the ingredients that goes into this dish, as well as the price. And each item can have different type of price by different type of size. So it's a fairly complex data structure. If I pass in on this URL to the Streamlit app and click script, now you can see that it extracts the full menu item. And for each minor item, it has name, ingredient, size, and price, where size will be an optional field. And we can quickly verify if it's correct. So the first item here is garlic bread, which if I go to this website, The first item is garlic bread, 2 pieces, $11. And that's exactly correct. And the last item is this cannoli, which has ricotta and pistachio with $8.2. So if I scroll all the way to the bottom, it is also exactly correct. So this is doing a pretty good job in terms of making large amount of content. But if you want to scrape something different like e-commerce site or car dealer information, you can just load a new website and then change the data model here. And this time the model will be a list of different products with product name, description, location, price, and list of images. And all we need to do is just passing on the different data model. And if we compare side by side with the actual website, you can see the data is correct with the right name, right price, right product description, and captured every single car on the page. And second category is improving large language model reasoning ability. So most of you probably pretty familiar with the tactic of chain of thought. If you ask large language model to think step by step, large language model can generate much better result. But the problem using chain of thought is that it basically output a huge amount of reasoning steps together with the final answer. So to get the final answer, you normally need to go through another data extraction or another large language model step to get the final answer. And this additional work, from my opinion, kind of stop developers from adopting chain of thought for many tasks that could have been optimized. But with the structured output, you can force the large language model to generate a list of reasoning steps first, and only after that, try to come up with a final answer. And you can just grab the final answer directly by getting the value of that key. It became extremely easy and simple to set up those additional reasoning steps to improve the quality. And you can even teach the large language model about what are the steps to think through before they come to the final answer as well. And last but not least, how can you leverage structured output to build more reliable agentic workflow? The best practice of building AI agents kind of switch from a free-form agent where you just give a list of tools and let it figure out what kind of process to follow, more towards kind of flow engineer type paradigm, where humans still control and define what are high-level steps and process, but use large language model to make certain decisions at specific points to decide which specific subpath to take. And to have this type of workflow works reliably, you need this ability for large language model to output only specific answers. For example, you might want to build a marketing agent where it will take a step of generate the blog first, then go through a large language model step to say if the content is aligned with what the user is requesting. If it passes, then go trigger the webflow to publish content. If it fails, go back to the previous step to regenerate blog again based on the feedback. So with this structured output format, we can define a Pydantic model where it will firstly do some reasoning to critique the blog content, then come up with a conclusion which can be either pass or fail. Because structured output format is 100% guaranteed, this means this flow will also be 100% guaranteed reliable. So now I'm going to get into details about how can you build 3 example large language model applications from web scraping, automated video editor AI, as well as dynamically generated UI based on the user intent. So the first example I want to take you through is a video editor AI. I basically want to build an AI video editor that can take any sort of YouTube video, understand what does this video actually talk about, and create multiple different shorts that represent the core highlights of this video. And the hard part of building such a system is actually identify the right timestamp of highlighted clips. And this is where the OpenAI structured output comes into place. So we can define this specific data structure that one, force the large language model to think things through before it gives us a random timestamp. And second, to making sure the format of timestamp it return is proper. And this should return a data structure looks something like this. It will identify multiple different highlights. And for each highlight, it will identify the main points it talk about, the title, as well as specific clips, so that we can firstly use service like Assembly AI to get the full transcript of the YouTube video with timestamp, and using OpenAI to extract specific clips and in the end creates a short video. So to do that, we will firstly import a few different libraries, and also in the .env file, we were adding Assembly AI API key as well as OpenAI API key. And there will be 4 different functions. The first function to download the YouTube video from URL, we're going to use a library called YTDLP. And then we will use Assembly AI Python SDK to get the full transcription, where I can turn on the speaker label, auto chapter, as well as IAB categories. So it can provide some sort of intelligence out of the box. I will also pass on some special words that are not well known, like LangGraph or LangChain. I can get a transcription from the service and then get a full transcription in the SRT format, which had all the timestamps. Then I will use OpenAI structured output feature to define the Pydantic model that we explained earlier, where I can define very specific format of the timestamp by adding descriptions here. If you want, you can also add in custom field validator but I found the performance pretty well, so I didn't really add it. I will pass on the transcription, get all the highlights, and return the full highlight clips. And in the end, I have this function called trim highlights, going to trim the video and put together all the highlights clips into a highlight video shorts. And that's pretty much it. I can try to transcribe this video that I just published last week by running the script. You can see it will download the video first, and Assembly AI will return the full transcription with timestamp, and then we will gather response and try to generate video clips. And if I open the folder, you can see there are 3 different shorts that has been generated from the original video. You can do something similar to generate a full blogs with both screenshots, video clip, and content. And next, I want to show you how can you quickly build a universal web scraper where you can take a URL of any website and script structured data format in a table. To do that, we will load a few different libraries we're going to use, set up OpenAI as well as define the model to be the latest GPT-4 model. And we'll have a few different functions. One is I will use Spider Cloud, which is web scraping service, to get a markdown format of the web HTML, and then use OpenAI to extract structured data. And in the end, I'm going to do some data transformation to making sure everything can be displayed properly in a table format. So firstly, I will create a function called a Spider Cloud script. Spider Cloud is a web scraping service that allows you to turn any website into markdown format with really high rate limit. I personally found it is better than the Serper service as well as the Firecrawl. So I will just use their Python API to get the website content into markdown format. And then I will use this extract data function, which we're taking the raw data as well as the response format that we defined somewhere else. So it's a pretty general solution that can extract structured information. And in the end, I will create a function called flatten JSON as well as flatten JSON array to transform the JSON data in a way that I can display in a flat table. And that's pretty much it. Now all I need to do is define the data structure that I want to capture. In this case, I want to extract the menu item from those restaurants. So I will define a menu, and for each menu item, there will be a name of the item, ingredients, and price. And you can also define different price for different size. I quickly use Streamlit to build a UI. And this is the end result you see here. So it's a pretty powerful universal scraper. Depends on the type of data you want to scrape, you can just change the data model here, as well as specific data that you want to display. And last but not least, I also want to showcase an example of how can you build a simple web app that can dynamically generate UI based on the user intent and prompt with Pydantic model like model rebuild. And that means you can output structure where it can be a child component wrapped under a parent component. And this is useful for dynamically generating UI by just giving large language model a few predefined components. There are already people on Twitter utilize this functionality to build some sort of automated form builder where a user can just give a high-level instruction about what information they want to collect, and large language model will generate the whole form based on the user intent. And I also built something similar in Python, utilizing the fast HTML library. So fast HTML is a new library that allows you to build full-stack web application using Python. You can build a UI component with complex interactions directly in Python, which is great news for many people who are not familiar with JavaScript. So to use fast HTML, you can basically set up an app server very easily, different sorts of endpoint. You can easily create the HTML format by using those tags. So in here, I will load 2 scripts first from Tailwind and Dicey UI, which are 2 popular component libraries, and put together a quick UI where it will have title as well as text input for user to give the prompt, and a button which will trigger the /GenUI endpoint that we're defined here. So every time when the button is clicked, the function we define under GenUI will be called, and the return value will be changed to the target item, which is div with ID customer UI, and fill in the inner HTML with what we generate from this endpoint. And under the GenUI endpoint, I define a function which will take the data that we receive from the form, which is prompt, and I create 2 simple data structure, which I basically ask large language model to generate plan first, and then create HTML immediately. And once it return response, we will get just HTML and then put it back. And you can do server to start the server very easily. If you haven't installed FastHTML yet, you can do pip install Python. But if you already did, you can just do python i.py to start a server directly. So I can come here and then ask it to create an NPS survey pop-up. Click on button. If you open terminal, you will see that it received a prompt and return back a div. So if I go back here, now it shows me this model about NPS survey. I can also try another one called weather UI card, which it will return me a UI card for display weather, even though the logo here is empty. But we can imagine later we can just replace this with real image URL. So those are a few quick examples of how can you utilize OpenAI Structured Output feature to really improve the reliability of your large language model application and also start exploring a few new use cases that wasn't very easy to do before. If you do want to dive a bit deeper into the code example that I showcased earlier, you can join my AI Builder Club community, where I will showcase step-by-step detailed code breakdown of every single example that I've showcased in this video. Plus, you have a chance to collaborate with other AI builders who might already experience the challenges that you are facing today. I have posted a link in the description below, so feel free to join. I'm really keen to see what type of use case that you start building with this structured output feature. This is a very exciting step for the agent future. If you enjoyed this video, please give me a subscribe. Thank you, and I'll see you next time.